there's a lot of things that we use in healthcare that we don't understand and that we can't explain. And this is when I think that AI often, what I call, it stimulates the mirror effect. So we worry about new things and we want to hold them to a very high level of evidence. And so, for example, we might say we need to fully understand something before we can use it. But actually, that then forces you to hold up a mirror to current practice and say, well, do we fully understand everything we're doing right now? Because if the answer is no, then I'm not sure that's a fair level to hold something to necessarily.
If, for example, we found one portion of the network that is very well associated with hallucinations, and if I can now lower that portion of the network, what I say like portion of the network, it simply means like thousands or tens of thousands of neurons that always activate when a certain thing happens. And you basically just, how you do this is just you run a million examples and then try to find patterns in the network that have activated when the model has hallucinated, and then run it again, but now try to lower the activations of that portion of the network. And they have found some like really nice results.
Early studies that have been done have certainly shown that having explainability doesn't improve the risk of automation bias, which we know is there. And some people felt like as soon as we get explainability, it will mitigate the automation bias risk, and it doesn't seem to be doing that. And actually, I do worry it could make it worse, especially for the more vulnerable groups to automation bias. And I think that this really deserves a lot more attention, this kind of behavioral science research part of this discussion.
I would like to see a confidence level, or I want the large language model to be able to say, you know what, I'm not too sure. I think that would be really useful. And, we're not training the models to do that. Like you said, at the moment, reinforcement learning, we're doing it towards human feedback, towards flowing conversation. And unfortunately, that means it ends up being very agreeable, and it doesn't prioritize factfulness or faithfulness to how you interact with it. So I think maybe we just need some data sets as well, where there is a lot of equivocal data, and maybe it's okay to say, I don't know. Maybe there should be benchmarks to teach the model to say, I don't know, I'm going to put my hands up on this one, but I'm not too sure. This could be it, but, maybe not. Welcome back to the Devanddoc podcast. Today, we actually have a merging of two podcasts. We have Devanddoc, and we also have Dr. Annabelle Painter from the RSM Digital Health Section podcast. Just a quick bit about Annabelle. She's someone I'm very happy to call a friend and colleague. She is a doctor working as a GP. She is also a chief medical officer in a company called Visiba that does health tech products, including triaging AI. So it's really fascinating. She's also a leader in kind of the healthcare, health tech space. So it's been really amazing to sit down together, the three of us, to talk through a really important topic of explainability and interpretability. We hope you enjoy this one. Hi everyone, and welcome to the joint Devanddoc and RSM Digital Health podcast. Today we have with us Dr. Annabelle Painter, myself, and Željko. Maybe we should just do a quick round of introductions for everyone. So maybe I should start. My name's Josh. I'm a co-host on the Devanddoc podcast. I'm a neurologist and an AI researcher. Over to you, Annabelle.
So, hello, my name is Annabelle Painter, and I am the host of the RSM Digital Health Section podcast. I am also a doctor by background, and I've spent the last 5 years working in digital health and AI space, working across roles in industry, in the NHS centrally, and in academia.
And I'm Željko. I'm the co-host of the Devanddoc podcast. My background is mostly in AI. The last 6-7 years, AI for healthcare, developing large language models, vision models, whatever basically is needed to somehow help doctors.
It's so good to have the three of us together because the listeners probably don't know this, but we've been working at some point in the same building with different teams, and we have just never bumped into each other in person in that building. And it's good for all of us to catch up virtually, I think.
Yeah, it's so nice to be able to do like a joint podcast with other people who are really passionate about this space. And I love what you guys do on the Devanddoc podcast. So it's great to be able to come together and discuss a topic.
Thank you. And likewise, I've actually been listening to a lot of your podcasts lately, and I really love the episode with Isomorphic Labs. I thought that was really cool.
Thank you.
But yeah, without further ado, I think, there's a million things we could talk about in healthcare and AI. And, we can talk about chatbots, large language models, multimodal models, everything. But I think today we sat down and we decided we need to talk about one big topic, and that's explainability and interpretability. Maybe I should just pass the first question to you, Annabelle, but why is explainability so important to you, and why do you want to discuss this?
Yeah, so when we were thinking about what to talk about, I really felt like this would be a good topic. And it's something I've wanted to explore on my podcast for a while. And I think the reason behind that is that it's something that's talked about a lot in the context of healthcare AI. And when people talk about explainability, it often feels like it's talked about in quite black and white, broad brush terms. So people will say things like, if we're going to have AI in healthcare, it must be explainable. And they'll kind of group it in with other things like healthcare AI, it must be evidence-based, it must be data secure, it must be cost-effective, and it must be explainable. And to me, explainability doesn't fit within that kind of category of kind of governance requirements. I think that when it comes to explainability, the discussion is actually much more nuanced and complex. And I think it deserves that kind of deep dive discussion. And I know how much you guys love diving deep into AI. So I thought this is a great opportunity to do that together.
Yeah, I think that's perfect. I do think also people have a bit of a mixed feeling. What is even explainability, or what's even interpretability? In ML, like with many other terms, these two are used interchangeably, even though they are not really. And I think when hospitals or clinicians or doctors are even mentioning these, sometimes there is some confusion on what they mean by the model being explainable or the model being interpretable. So I think it's awesome to address that a bit in more detail.
Can I just address that statement? For AI to be used in healthcare, it needs to be explainable. I think that's quite a sweeping statement. And I don't know, I feel like a part of it stems from doctors maybe not fully understanding AI, or maybe having a slight worry that it could do the wrong thing. And there definitely are those cases. But I think one of my concerns is, as models get better and better, we're moving away from this narrow AI. So historically, we say narrow AI is an AI that's used for one specific use case. But we're moving more and more into deeper models with more and more layers and networks. And as we go deeper, I do wonder, is it possible to get true explainability with some of these models?
I totally agree with that. And I think it does come often from a place of fear of the unknown, this sense of we don't understand how AI makes decisions, and that's unsafe and we can't possibly use it. And I think a lot of it comes kind of linked with this idea of trust. So how can you possibly trust something when you don't understand how it makes decisions and it doesn't explain itself? But I think there's a lot of assumptions and insinuations to unpick there in that kind of implied suggestion about trust. And I think if we just strip this back a little bit to trust and explainability and understanding things in healthcare, there's a lot of things that we use in healthcare that we don't understand and that we can't explain. And this is when I think that AI often, what I call, it stimulates the mirror effect. So we worry about new things and we want to hold them to a very high level of evidence. And so, for example, we might say we need to fully understand something before we can use it. But actually, that then forces you to hold up a mirror to current practice and say, well, do we fully understand everything we're doing right now? Because if the answer is no, then I'm not sure that's a fair level to hold something to necessarily. So just to give like a basic example, I mean, Josh, this is probably a good one for you, being a neurologist who deals a lot with pain management. If I was to say to you, please explain to me how paracetamol works.
That was the exact thing I had in mind. We still don't know, long story short, and we use it everywhere, right? It's sold over the counter, it's used in hospitals, and it's unbelievable. We still don't know how it works, but we do think it does work, right? It does take the pain away.
So yeah, and I think the crucial thing here is it doesn't necessarily matter that we don't know how it works. What matters is that we know how to use it safely, when it's indicated to use, how much to use, what to do when too much is given. You know, all of these things around the safety and the appropriateness and the parameters. That's what really matters. And, you know, giving other examples like general anaesthetic, we've got no idea how general anaesthetic really impacts consciousness. We still don't really understand consciousness. So first, like basic point is there is a lot in healthcare that we don't understand. So fully being able to explain things, you know, is simply not something that we always do in medicine. I think as a, you know, playing devil's advocate to that position, you could say, well, it's not really fair to compare AI to a drug. They're very different in what they're trying to achieve. We're talking about AI here that influences clinical decision making or that's giving you a decision. And it's much more appropriate to compare that kind of AI to a human, right? And say, well, at least if I was to ask you as a doctor, Josh, to explain why you diagnosed someone with something, you'd give me a good explanation, right? You could tell me why you came to that decision. But then I think the counter to that is that as humans, we're not actually very good at explaining our decisions. We think we are. But actually, if you look at lots of research into this, we often confabulate answers to why we've come up with decisions that aren't necessarily the truth. You know, there's really interesting study on this from split brain patients that you might be familiar with, Josh, as a neurologist, where, you know, if you split the brain in two and you show, for example, the right hemisphere of your brain, so you show the left side of the visual field an instruction like go for a walk, and then the person will go up and go for a walk, and then you ask that person why they are walking. Now the language part of their brain is generally often on the left side, and if that's the case, they'll then come up with a justification like, oh, I was going to get some water, you know, and they'll be sure that that's why, but that's actually not why. And that's obvious in these kind of patients, but we do this kind of confabulating all the time and kind of post hoc rationalizing all the time.
Yeah. And you know, the entire, you know, a lot of psychiatric and psychological interventions, we also don't really know how they work, right? We have theories of the mind. And yeah, I think you're right. Like if I give a certain treatment or make a certain decision clinically and I'm asked to justify it, I definitely can, but how much of that is also like post hoc kind of rationalization, right?
I was just going to say we have a lot of respect for clinical intuition as well, and understanding that sometimes you just have a sense that something might be wrong. And I think that's part of the reason why on 2-week wait referrals, for example, one of the categories you can put is just clinical concern, even if that patient doesn't tick the boxes required for a 2-week wait referral category. And I think that's right, that we do acknowledge that there is this just clinical sense that there could be something wrong. But I think we also just need to appreciate that's because sometimes we can't really delineate the exact reasons why we've made a decision.
There is a lot of that gestalt, right? Like a patient walks in, I think we develop this feeling like an unwell patient or someone with an underlying, you know, problem. Sometimes it's really hard to put into words, but you must have worked, well, you know, I work as a medical registrar, but you must have worked, especially during nights when you're busy, there are many, many patients. You do gain some kind of idea just by looking at them, you know, whether that's someone to worry about. And so far that intuition has proved to be, you know, pretty accurate, actually, looking back at previous experiences.
But I think you are just like... Yeah. Talking about this and listening, I think you're just basically talking about double standards. Like on one side, we are talking about medications that we don't really know how to work, but we have evidence that it works, even though we don't really understand how. And on the other side, also talking about clinicians having intuition, which basically just means, okay, they don't really get why, but they're saying this should be. And then on the other side, we have AI that we're asking, okay, now we have to perfectly understand every little detail for these to be used in healthcare, which just seems like there's a big difference. And it's also a question, why? Why is it so? Why do we have to be so rigorous on the AI side, but don't have to be rigorous on a new medication for, I don't know, depression?
Yeah, exactly. And even if I give you an explanation, just conceptually, how that explanation comes into my head, the different neurons that activate as I'm explaining. I don't know. I always think like it's a bit like a large language model. You ask it something, oh, why did you say this? It might give you an explanation that sounds tangible, and it definitely makes sense. But you do wonder what's happening on that lower level as well. There could be all kinds of biases baked in to that response. But Željko, why don't we go into a bit of a history and maybe a bit of an explanation of explainability?
Yeah, of course. I think the first thing is just the difference between interpret and explain, just to make a difference here. Interpretability simply means that we can look into the model and understand why did it make a decision. So like if you look at a simple model like a decision tree, it basically assigns different weights to different input features. So if your input features are like, you are trying to predict should someone be hospitalized or not. And then the input features are body temperature, do they have hypertension or not, do they have diabetes or not, and so on. You can interpret the prediction of a model by basically looking at this decision tree and trying to understand how did it come up with these decisions. So this is the interpretability part. Explainability, on the other hand, is we can in some way explain the result of the model. It does not have to be directly looking into the model, but it can be maybe using other tools, using some statistical methods, using some other smaller models that we will see in a second. Like the second area is in fact much more popular in more recent deep learning models that are extremely big and hard to understand. So like explainability, we can explain how did a model come up with a prediction, with a decision, basically.
I mean, my understanding is, interpretability is a more simplistic look. So I use the analogy of like a neuron, right? So like a linear regression model where you know the coefficients, you know the features that determine a certain output. I'd see that as an interpretable model, whereas explainability is a bit more high level. Like you may not even know what's going on the individual level, but on a grander scale, there is a explainability there that you can understand.
Yeah, you can explain the decision the model made just based off of maybe some input features or something. There are attempts in also trying to do the same in very large models, but it is just much more difficult than in a model with, 5 parameters. It's very easy, but in a model with 5 billion parameters, it's a bit tricky. So with respect to history of this, I mean, initially in the 70s and 80s, most of AI, as we know, was like rule-based. So there was not really too much need for interpretability. I mean, if I wrote the rules, I basically know how the model works and I can look at which rule activated for these predictions. So you could have a rule that is, if it's hypertension and diabetes and very high blood pressure and really high body temperature, hospitalize these patients. So it's straightforward to tell and explain basically this very simple AI model. Over time, these got a bit more complicated. Initially, smaller models or simpler models like decision trees and even random forest and like logistic regression, those were basically the next step after the rule-based ones, were still like very simple to explain. Logistic regression assigns a weight to each one of the input features, and based on the weight, I can say, this model gave a very big weight to do they have hypertension or not, versus a very small weight to, the height of the patient, for example. Then after that, we go into the area of neural networks. We also have a bit like SVMs and other like more statistical models. And this is where things get a bit tricky. With small neural networks, it is still fine. As I just mentioned, like if there is a couple of neurons inside, you can basically even understand the path through the network and understand why was a decision made. But the moment we went into multi-layer perceptrons, then these got a bit more complicated. And we couldn't really look anymore into the network to understand why was a decision made. And this was especially pronounced with more recent models, large language models and similar, where we almost have no idea what's happening. There is millions of things inside and something gets activated and it works. There are some attempts, but we are still mostly in the dark on how and why they work so well. And in fact, how do we interpret a decision? Now, some of the recent methods to explain these, so I'll just mention a couple, but we can go into some other a bit more in depth. So for example, one of them was gradient-based saliency. We have even used these methods for like a very large model that we have recently done called Foresight, which is as input taking a patient's medical history and predicting what is this patient at risk for. And this gradient-based saliency allows us to calculate what was the most important feature for the prediction. It basically calculates the gradient of the input with respect to the output. And if the gradient of an input is very large, it means that feature is very important to the model. And if I now put this in the perspective of foresight, it simply means that I can now understand what disease or what symptom in the patient's past was the most important for the prediction of the future risk.
Željko, how is the gradient calculated? How does the model understand?
So the gradient is basically calculated the same way you would do backpropagation. You're just backpropagating based on the output of the model. And the gradient is simply gives you like the gradient of a network tells you how does the change of something in the network affect the output. So if I calculate the gradient of the whole network, I will know what will happen if I change each one of these features. So if the gradient of something is very large, it means that changing that even by a slight amount will drastically affect the output. Which now means if I calculate the gradients for the input features, I will now know if the gradient of the input feature is extremely large, this will affect the output in a very significant way. And if that is true, then it means that feature or that disease in the input or symptom in the input is extremely important for the model.
Is that the same kind of methodology that's used to produce heat maps in imaging AI explainability?
It can be used in vision also. In vision, there are basically many different ways we do this. Some things is, for example, one of the famous ones is we are trying to understand which of the layers of the network focus on which part. So we'll basically get, the first layer of the network is focusing only on edges. The second layer is now focusing on concepts, which can look into, humans or cats or dogs or whatever. The third layer is focusing on something third and so on. But what you were just mentioning, these gradient-based saliency, can basically be used in the same way with vision networks so that we get which part of the input image is the most important and which one affected the output the most. And changing that input part even slightly will drastically change the output. So heat maps, yeah.
That's fascinating. So what other methods are there, Željko, apart from gradient saliency?
Yeah, so one interesting one is called LIME. It is local interpretable model-agnostic explanations. Now, I'm not too keen on the model-agnostic. It is not fully model-agnostic, and there are some things that are a bit problematic, but it is a very interesting approach. What it does is basically this one works on a specific prediction. So it is not explainability for the whole model and how does the whole model work, but it is once we have a specific prediction for the model, now we are trying to understand what was important in the input to make this prediction. You'll notice a pattern here. We are always trying to understand basically what part of the input was important for this model to make a certain prediction. And Lime works by slightly changing the input and then seeing how does it affect the output. And with this, so we basically do these permutations many times. And then based on the new output from these permutations, we train a much smaller model, like a decision tree, on these permuted inputs and the new outputs. And then this much smaller decision tree is now able to tell us what was important for the big model to make the prediction. So it is basically, we are trying to use a very small model to explain the big one for a very specific example.
So for an image, is this basically the same as perturbation? So for an image, for example, you're changing a couple of pixels or areas and seeing if the output's different.
Yeah. So if for an image, it would be something like that. Assume like if you have a model that takes in blood pressure, you would basically move the blood pressure a bit up, a bit down and see how did it change the input. And if you have something that drastically affects the input, then the small model will learn to understand that, okay, changing this even a bit changes the output a lot. Or if changing something doesn't affect the model at all, then the small model will learn, because the small model is basically trying to find the most important features.
I just wanted to give an example, a text example, which I was working on. I was trying to classify patients of cancer as to whether they were an active smoker, an ex-smoker, or a non-smoker. And actually I took not a bad data set of cancer patients from St. Thomas's, and I had about 100, about 10,000 patients. And I took snippets of text that mentioned the word smoking or its synonyms. And I trained the BERT model, so like a bidirectional transformer model, to basically try and classify these lines of sentences of text as to say whether the patient is a smoker or not. But surprisingly hard thing to do, right? Because as doctors, we don't always write, patient is currently an active smoker, right? Like we often write, smoking history of 5 years, or patient has a 10-pack year history. And I was doing my own perturbations afterwards because the model was trained. It was pretty good. The metrics was 0.9, recall, and pretty good sensitivity. But I couldn't figure out how it classified. So I was changing certain words. I was changing the patient stopped smoking 5 years ago, stopped smoking 4 years ago, 3 years ago, 2.5. And then at a certain point, they were changed between the smoker and the non-smoker. But I don't know, I see that as kind of explainable, but also not really, right? Because I still don't really know exactly what the time limit or the combination of words which a model would take to classify someone as a smoker versus a non-smoker or ex-smoker.
Yeah, so in that case, you were basically manually doing this approach.
Manual.
You were trying to understand what features were important, what not, and by looking at the model. This approach would basically be a bit more systematic in a sense that you will generate thousands or millions of perturbations and then fit a decision tree and then try to understand why was a decision made. But again, this is given a specific input and a specific output. So this will not explain to you why is a model overall making the decision someone's a smoker or not. It is explaining a specific example. So in that sense, it can be a bit limiting because for every new example, you would have to rerun this whole procedure and then try to understand. And especially it's limiting. So that's why I'm saying it's model agnostic is a bit questionable here. Very large model and very complex inputs. The number of perturbations or small changes that you can make are almost infinite. Like if the model is, for example, assume the model is taking an hour of a video and then in the end predicting something like, is this patient feeling well or not? It is nearly impossible to, like, the amount of perturbations you can make in that hour of a video, the amount of pixels you can change and frames you can remove makes no sense anymore. And then it gets a bit hard to use this approach.
I also think listening to your conversation has highlighted an important point when we're talking about explainability and about what we mean by explainability, which is, are we referring to explainability of a specific clinical decision or explaining how that model works generally? Because those two different types of explainability can serve different functions. So the first one, I think, is what people are thinking about when they say that a model is explainable. They want each decision to come with an explanation. But the latter form, where you're actually just looking more holistically at the model, is what is more, I think, of what we've been seeing to date, especially with things like heat maps and things like that. And there's certainly question about whether those more traditional models that you've been talking about there, Jarko, really can be used on an individual decision-making purpose, because I think they do have use, and certainly they've raised issues with models. Like there's good examples where it's shown that chest X-ray AI is actually been diagnosing people based on whether the X-ray was kind of AP or PA, or whether there was any kind of other kind of interventions being used on that individual, like where they had an NG tube in, where they had ECG leads on, these kind of things. And actually those kind of general explainability metrics have been good for detecting these kind of cheat mechanisms, you could say, that AI is using. But they're not very useful for going, like, I think what you were just talking about there, Josh, is going like, well, in this case, this person was said they were a smoker or not because of this number. And then you look at that and go, but that doesn't make sense because the number says they have a 1-year pack history or something. But it's just because that's the general area that the model's looking in.
Yeah. Yeah, there's I found the word for, that's called nonsensical correlations in the AI world. And there's a million of these examples. I think, like you said, the chest X-ray is one. So there's a really good case in dermatology, right, where essentially they tried to teach a deep learning model how to pick out malignant skin lesions. And so they fed it millions of photos, well, not millions, but thousands and thousands, different lumps and bumps, some malignant, some benign. And the performance was amazing. But actually, when they looked at these heat maps, they realized that it was actually paying attention to skin markings. So they basically found that the dermatologists, because they highly suspected those malignancies were those lesions were cancerous, they were drawing on them or putting a ruler next to them, and that was in the photo. So the model actually learned the association with these measurements as a malignancy rather than paying attention to the lesion itself.
Yeah, I think that's a perfect example. And I think because of that, we really need we need the interpretability, because we want to basically see what is the model paying attention at. If we could basically take that image and do a heat map, and now we see, the model is not paying attention at the malignancy at all. It is really paying attention just at the ruler marks or whatever. We'll be like, this doesn't seem right. And the same is in text. If you see the model is paying attention at the right part of the text, which is, mentions a disease or a symptom or something, versus paying attention at the way the doctor wrote a sentence, because it can be just the way you write something. You basically can convey that, you're very worried about this patient or something bad might happen or something like that. So I agree that explainability is very important.
I'm aware we've kind of cut you off while you were talking about different types of explainability, Jarko. So could we maybe talk now more about the more modern approaches that people are taking in the last few years?
I think these, the ones I was just mentioning, these are fairly modern and are like salience-based gradient-based saliency, is even today used very often, especially in NLP. Some things that people are recently doing that we haven't touched upon too much is like Anthropic has done very nice papers in this area. they are trying really to understand the inner workings of the model. So they are trying to understand, for example, is a portion of the network focused on a specific topic? Does the model somehow inside of that giant neural network have areas or patches that activate when, for example, it's lying? And this, like, you understand immediately how important this is, because if we can understand that a portion of the network will activate if the model is lying, or if the model is not confident, or if the model is talking about specific topics. So I think this famous one, at least on Twitter, was the San Francisco example, or the Golden Gate Bridge, which it was like they found a portion of the network that activates really well, like really hard, when the model is talking about the Golden Gate Bridge. And what the researchers have then done is they asked the model a random question like, oh, hey, how are you and what do you do? And then artificially activated that portion extremely. And the model started saying, oh, I'm the Golden Gate Bridge. I'm doing very well. So basically, like, they found a portion that made them like have a identity crisis. They didn't know anymore what to do. But you also like get how this is more, because what we can do is lower the activation of that part. If, for example, we found one portion of the network that is very well associated with hallucinations. And if I can now lower that portion of the network, what I say like portion of the network, it simply means like thousands or tens of thousands of neurons that always activate when a certain thing happens. And you basically just, how you do this is just you run a million examples and then try to find patterns in the network that have activated when the model has hallucinated, and then run it again, but now try to lower the activations of that portion of the network. And they have found some like really nice results. But this again, I think this is, Annabelle, what you were mentioning, this serves a different purpose a bit. It serves a purpose to understand how and why is the model doing something, so that we can basically improve the model versus explain why was something done.
It's really fascinating, that description, because to me there's a lot of analogies there, like going back to what you were saying earlier, Josh, comparing the really early interpretability to looking at, say, the propagation of an action potential down a neuron. And actually now that neural networks are so complicated that you can be given the information about all those action potentials, but it's completely uninterpretable because it's too complicated. In the same way, if we gave you that information about the brain, it doesn't mean anything. But what we do use in the brain is things like functional MRI, where it goes, well, this part of the brain lights up when we think about the Golden Gate Bridge. And it's almost like we're abstracting the neural networks out to that level, where actually it's not about the individual numbers and the individual parameters. It's about actually the areas. But I do think there's also danger in thinking about it in the way I've just described, because it really anthropomorphizes AI, and it gives an insinuation that the way AI thinks is how people think. And actually, I think this is another issue I have with explainability, is this assumption that we'll get AI to explain itself because it will explain it in human understandable reasoning terms. And I think it's definitely plausible that AI is coming up with decisions in ways that we are not capable of really ever understanding, or can't really be explained in human understandable reasoning ways. And I think if we can't get there, if that becomes impossible, I don't think that should be a barrier to using these models. And I think there is a risk that we try and anthropomorphize them too much, and we ask them for human explanations when actually that's maybe not the ideal thing to be doing.
Yeah, maybe it's like not even possible to explain, because we were mentioning this example a couple of times, which is the retina scans, where the model just based off a retina scan is able to determine the sex of a person. And we cannot even explain it because we don't know what the model is looking at. For us, it is impossible. And looking at the features that the model is looking at, we don't really see anything. Even doing like the heat maps and all of that, you're like, okay, I mean, the model has focused on this part of the image, but it doesn't tell us anything. So like, would it even, as you, Annabelle, just said, maybe some things are impossible to explain, or explain in a way we can easily understand. I don't know.
what I'm interested in, I think it's fascinating. We have had historically a virtuous cycle, right, between neuroscience and AI, and how it designed the neurons in AI has been inspired by the brain. But yeah, sometimes I do think, I don't know, working as a neurologist, I can see similarities, but I can also see the danger in anthropomorphizing these models. I think what I'm interested in as well is, how the clinician then interacts with the model, right? So even if you build this apparently explainable model that highlights certain areas which it's focusing on, I wonder, how much of that then becomes the user's bias, right? We might see it's highlighting a place that we were thinking of, but does that immediately mean it's the right decision? I don't know. I'm really interested in this AI clinician interaction as well.
This is also something that I'm really fascinated in, and I think it's really under researched. I think there's a lot of excitement and research going into explainability, but not much into what does having explainability mean in terms of influencing the clinician decision. And I think what concerns me is the risk that actually having some kind of explainability could worsen automation bias. So by automation bias, I mean the tendency for clinicians to uncritically trust an AI output. And I think, imagining a scenario where, especially those clinicians who aren't as personally experienced in an area or confident in making decisions about an area. So, let's take me, working in general practice as a generalist. If I was asked to interpret, an X-ray, let's say it's like an X-ray of an ankle, like querying a fracture, and there's an AI there saying this is a fracture because there's an area of, I don't know, something that looks like a fracture in this part of it, and it sounds very plausible and convincing. I think there's a tendency that because that explainability is there, it makes me more likely to trust the judgment. And that there's this phenomenon in psychology called placebic information that I think is quite interesting, that basically suggests that if you're given, if someone gives you a statement and then gives you a justification for that statement, even if that justification doesn't really make that much sense, not that coherent, you're more likely to go along with that just because there's a justification there. And I think this is unproven I'm not saying this will necessarily happen with explainability, but I do think that early studies that have been done have certainly shown that having explainability doesn't improve the risk of automation bias, which we know is there. And some people felt like as soon as we get explainability, it will mitigate the automation bias risk, and it doesn't seem to be doing that. And actually, I do worry it could make it worse, especially for the more vulnerable groups to automation bias. And I think that this really deserves a lot more attention, this kind of behavioural science research part of this discussion.
That's fascinating. I can think of examples of how this placebic information happens in real life, right? Like for sure, discussing with colleagues that we often say, "Oh, yeah, I read in the literature, this could happen." You immediately that statement becomes so much more trustable. Oh yeah, later studies show this. So, and when you actually dive into it, it's like, what study?
Yeah, and
case report?
You see it a lot in kind of alternative medicine pseudoscience arenas, right? Where it will be like, take this nettle juice, it contains vitamin C is linked with this, and it's something that sounds very plausible, right? And it kind of makes sense to a lay person that might, and so you're more likely to believe because there's this kind of pseudoscientific explanation there, even if that doesn't really hold to scientific scrutiny or to like when you think about it critically. I think oftentimes our brains aren't fully engaged in, critically appraising every bit of information, and they can't be all the time. We can't be 100% vigilant all the time. And I think I do worry that the presence of some kind of plausible explanation could worsen the risk of automation.
It is very interesting that there are not many studies on this. I mean, on one side, it's a bit normal because models explaining stuff in natural language is not that old. We only have these for a couple of years now, so maybe it was not, the field didn't mature enough for us to be able to have such studies. But it is very interesting, and that would be an awesome study to have, because these models are extremely good at explaining what they do and at convincing you that is the right thing. It's like, it is very eloquent. It is very nicely said. It is like a very professional language. So you immediately start trusting it, even though it's like a complete garbage. It doesn't make any sense what it's saying, but it just looks very, very nice.
I think you're talking about large language models, aren't you? And they do produce very plausible and ridiculous explanations. Actually, we were doing a session at Rewired on this, looking at comparing the outputs of large language models to clinicians' judgment. But one of the cases we ran through it was asking an LLM to do a dose conversion of opiates. And what was really fascinating about this output is it came with, without asking for it, a really in-depth justification and explanation about why it did its dose that it suggested. And that contained calculations, and it talked about ratios of the appropriate drugs. But what it actually came out with was a dose of an opiate that was about 300 times higher than it should have been. But you can totally see how, to a layperson reading that, this looks really convincing. And this kind of explainability is obviously concerning, but that's what LLMs would produce. Not that they claim to be explainable, to be clear, but if you ask them to explain, that's what they produce.
I think that's a great example. And actually, Jelka, going back to that Anthropic paper you mentioned, how they could, by the way, I don't think we explained this, but Anthropic is kind of like a safety first large language model company that's very big at the moment. But on that same paper where they identified, the Golden Gate Bridge thing, I just remembered they also identified a cluster of, we call them neurons, that activates their kind of flattery function. So if you speak to, like you said, if you speak to ChatGPT or the different models like that, they will often tend to flatter you and they'll say, oh, that's a great idea, or so they actually activated these neurons and the flattery just became completely insane. It was basically calling the user like a god and stuff. And oh, you are as wise as the god, like you're as beautiful as the
Give me that.
flowers. It was just fascinating.
We all need that. You want a bot on your counter at home that you can dial up to 10 and be like, okay, tell me how I look.
Jelka, I'm interested in your perspective on where you think this is going. Like, what's exciting you or interesting you in this field of explainability? Do you see there being a shift in the way that we design models or the way that people consider explainability when it comes to healthcare?
I think what we have done with the recent models, which was a bit wrong, is we aligned them a bit too much to human preferences. Like all the talk the last couple of years was aligning to human preferences and all of that. And I think we have overdone that a bit to the point that the model is not like honest or doesn't tell the truth anymore, but tells something that will please you, which is very, of course, very bad for healthcare, but like very obvious when you do stuff like the model gives you an answer and then you tell it, oh, are you sure? I think that might be wrong. And then oh, you are right. I was completely wrong. Now I'll give you a completely different answer that is like disconnected from basically what it told you above. Especially it can be pronounced in areas where like the model is uncertain, which of course for diagnosis is like if you are trying to diagnose a patient or suggest a medication in, I don't know, let's say mental health, obviously there will be very, very many possible options where you can skew it very easily. So I hope we'll start to go a bit more into the direction of trying to get the model to hold to the truth, what it thinks is true, and that it's not that easily swayed to a different direction. And then a bit explainability around that, explainability around the concept of truth, and explainability about holding basically the thought, not just switching around immediately. Because I think it will not be, the explainability will not go into the direction of the model gives you an output, you ask, oh, explain that, and then it gives you a paragraph. I think it will be more a conversation where you're asking many, many different things and trying to understand why did the model make a decision. And you want it to hold true to the decision it made and not immediately switch around and be like, oh yeah, you are right, I made a mistake.
Do you have any sense of what? So I think you're right in that the current LLMs out there don't have this capability to truly introspect or explain their decisions. But do you have a sense of what might be needed to get there? Like, well, what is the missing link that would get these models there? Or is that too difficult question?
I would say the biggest thing that is missing in the current models, this goes a bit philosophical, like in all of these discussions, but is ground truth. Because most of these models are trained on text found on the internet, and there is not too much ground truth there.
Like a world model, the idea that a world model is needed.
Exactly, yeah, world model, something that understands how the world functions and something that knows that if this happens, then that. There is no other option. If I drop a ball from a height of 2 meters, it will go down. There is nothing else that can happen. And it needs to understand, like it needs more of that concrete knowledge. And I think the same is probably in healthcare and medicine, needs more of that really concrete, chemistry, whatever is needed to ground the models a bit more and make sure that it understands what is 100% the truth, and then it understands what is a bit out there maybe. Annabelle, I just have the same question for you. Like, what do you think is basically both of these aspects? What are the models maybe missing? And also, what would you like to see in the explainability area for healthcare? Like, what do we don't have, and what would you like to see in the future?
So I feel like thus far I've kind of given the impression that I'm a little bit anti-explainability, but I just want to clarify that I'm not actually, and I'm very pro-explainability. And I should say that I actually work at a company called Visiba where we have an interpretable, explainable model, and I can really see the power of having that, being able to see how these models have made a decision. It means that we can also feed back in and edit how the model behaves and improve its performance over time. So I think if we can produce explainable, interpretable healthcare AI models, I think that's brilliant. And I think more research should be done into getting us there. But I also think that needs to come alongside this behavioral science research about, how does having that kind of information affect clinical decision making? And again, that's something we're currently doing at Visiba is conducting a trial like that looks at actually how having certain metrics presented to users affects their clinical decision making. So I think that's a really important point for me, is that we don't forget that side of the equation, that part of the research. I also think, though, that we shouldn't see explainability as a must. I think we should see it as an ideal and a nice to have, but it shouldn't stop us from deploying models that are proven to be safe and effective, if that's possible to do. Because I think if we see it as a must have, we might limit ourselves from using really effective AI technologies that possibly will never truly be able to explain. And I think that would be, potentially lead to patient harm that otherwise wasn't necessary by using these models. In terms of what's missing from LLMs, Jaco, I agree with you about the kind of world model. I don't think I've got much more to add there. And I think that's, if we can get to combining, so I work with a probabilistic Bayesian network, and I think if we could combine something that has this kind of understanding of Bayesian probabilities with like a large language model with its functionality, I think that could be really, really exciting. So yeah, I think watch this space, but I think that excites me about the future of possibly explainable healthcare AI.
Very nice. And Josh, I just talking about this now, I had another question that is probably perfect for you. Do you think that we are maybe using these models now a bit in a wrong way? In a sense that, should they be more conversational? Like, currently you ask the model, should this patient be hospitalized or not? But maybe that's not the way they should be used. Like, if you ask it this way, then the model is forced to justify why it thinks something. Maybe like it is this. I'm just looking at this from a perspective of how would you do this if you had a colleague working with you? You would not ask them, should we hospitalize? But okay, let's think about the case. Let's understand the past. Let's more as a colleague or something.
Yeah, I think let's wrap it back to the first question, right? Does all AI in healthcare needs to be explainable? And I think we agree it depends where it sits. And I think that kind of follows from your question. Are we using AI the right way? I think I think if the AI has a higher clinical risk, that demands a higher level of explainability. And yeah, maybe it's about how you use it. Because, for example, at the moment, there's this huge booming gold rush to create ambient clinical documentation scribes, right? AI scribes that can document for you, do administrative tasks. And we need to ask ourselves, does it matter if these models are not that explainable, if it's just drafting letters and then we're editing it and then sending it off? Versus, like you said, if you have a clinical AI model working clinically, then it probably does need more explainability and also a lot more careful thinking about where in the clinical workflow it actually sits. And I think that's why, we always say this, I think that's why doctors and developers need to work together. I think the one thing I would like to see, tying in with Annabelle's point of having kind of Bayesian, explanations, is I would like to see a confidence level, or I want the large language model to be able to say, you know what, I'm not too sure. I think that would be really useful. And, we're not training the models to do that. Like you said, at the moment, reinforcement learning, we're doing it towards human feedback, towards flowing conversation. And unfortunately, that means it ends up being very agreeable and it doesn't prioritize factfulness or faithfulness to how you interact with it. So I think maybe we just need some data sets as well where there is a lot of equivocal data, and maybe it's okay to say, I don't know. Maybe there should be benchmarks to teach the model to say, I don't know, I'm going to put my hands up on this one, but I'm not too sure. This could be it, but, maybe not. Yeah.
No, I think that's exactly true. And that's also why I was asking this question of, are we using it the wrong way? Because I think currently we are forcing the model to answer. Mm-hmm. We are forced, like if the model says, okay, this patient has diabetes, we are forcing it to justify the decision of it has diabetes. Maybe even though the model was not too confident, maybe the model was somewhere on the border of not sure what to do, but because we are forcing it, you said diabetes, now explain why. I think maybe the model should go more into a bit more on the exploratory side and be able to also say, I don't know, or be able to say, oh, maybe we need to do another test and then think about that, or a bit more in the not always exact truth, because sometimes given the input data, you cannot predict what we are asking from the model. And the model is basically making giant assumptions and with that making a mistake. But because again, we then force it to justify the explanation, it's making whatever, it's hallucinating in random directions.
It's kind of going down a rabbit hole, following its own initial judgment. Yeah. And I totally agree with you, Josh, about the kind of confidence or uncertainty estimate of a given answer. I think that would be hugely valuable in healthcare, but also outside healthcare as well. Look, I would love to speak to you both much longer about this topic. I think it's so fascinating. There's so much more we could talk about, but unfortunately, I think we have reached time. I just want to thank you both so much for doing this together. It's been really interesting to chat with you both, and perhaps we can try and do another one in future.
100%.
Of course.
All right. Let's pick it up again soon. We'll see you later.
Thank you very much for listening. I hope we have made this area a bit clearer. And thank you very much again to Annabelle for joining us. And we hope to see you again soon. Bye-bye.